Hey everyone, this is Kunal Abhijit here. I'm Iot Intern at Emertxe Technologies. I build a home automation project. Today I'm gonna give a presentation on IoT based home automation system. The contents that are included in this project are topics during internships, IoT architecture, embedded system, and project required elements, and all the conclusion and implementation of the coded. Topics that I learned during internships are C programming, keywords, basic data types, conditional constructs and looping concept arrays, pointer foundations, built-in and user-defined functions, storage classes, preprocessor derivatives, and header files. I also learned about C++ programming and object-oriented programming concept and introduction to Internet of Things and its architecture, and also introduction to embedded system definition types and embedded system concepts of embedded system, peripheral of light emitting diode, Arduino UNO, and 14 pins description of CLCD ADC use of analog to digital converter in Arduino, in which I learned about light dependent register sensor to read the sensor values, and based on the reading vary the brightness of LED garden lights. Temperature system, it consists of heater, cooler, LM35 temperature sensor. We can read the temperature from the temperature sensor serial tank. Now we'll start with IoT. The Internet of Things is the network of physical objects that contain embedded technologies to communicate and sense or interact with the internal states or the external environment, in which with more than 7 billion connected IoT devices today, experts are expecting this number to grow 10 billion by 2020 and 22 billion by 2025. Here is the IoT architecture, and here is the embedded systems components that are being used by embedded systems. Embedded system is any combination of hardware and software which is intended to do a specific task can be called an embedded system. It has three parts: software, firmware, and hardware. Here is the embedded system complete architecture. Project requirements are in control garden lights on basis of sunlight intensity, laser, the sensor brighter, the garden lights, temperature system control, and water tank control. And the requirements in this are hardware requirements: Arduino UNO, Israel W5500, PCF 8574, temperature sensor, LCD, LDR, and light emitting diode. All these operations will be done by Blink IoT app. Here is complete information about Arduino UNO. Arduino UNO is based on an ATmega 328P microcontroller. It is programmed based on IDE, which stands for Integrated Development Environment. It can run both on online and offline platforms. Here is the overview of Arduino UNO. Now here is Ethereal W5500 hardwired TCP/IP embedded Ethernet controller that provide easier internet connection to embedded system. And here is the support power down mode and support wake up on lane over UDP. Here is the overview. Here is the CMOS circuit of PCF8574. It provides general purpose remote input-output expansion for most microcontroller families via the two-line bidirectional bus. The device consists of an 8-bit quasi-bidirectional port and a 12-bus interface. Here is the overview of temperature sensor. It senses about the temperature of its environment and converts the input data into electronic data or record monitor or signal temperature changes. Here is LCD HD 44780 overview. Its driver's LCI displays alphanumeric and symbols. It can be configured to drive a dot matrix liquid crystal display under the control of a 4 or 8-bit microprocessor. Here is the light emitting resistor sensor overview. Basically, LDR is a component that has a variable resistance that changes with the light intensity that falls upon it. This allows them to be used in light sensing circuits. Here is when we use Blinkit app when we load the hex file. Here is the light emitting resistor when LDR is high, so LED is on. Light, light dependent resistor is low, so LED is off. Here is the overview. When the cooler will be on, then it will be overview like this. When the cooler is off, then the overview of the system will be like this. When the heater is on, then here is the overview of Blinkit app, and here is the overview of the system. And this is the overview when heater is off. When the inlet bulb of water tank is on, then overview will be like this, and here is the view of Blinkit app. When the inlet valve is off, here is the overview, and the overview of outlet valve when outlet valve is on, the overview of the system will be like this. When the outlet valve is off, then the system overview will be like this in Arduino UNO. Here is the Blinkit app notification of heater temperature, and here is when the heater will automatically turn off when temperature rises about 35 degrees Celsius. Notification of water level in Blinkit app will be like this. Water tank is full, inlet bulb will automatically turn off and it will be notified here. It will be show about water volume level. And overall conclusion is using Blink IoT application and Pixim Lab simulator, simulated home automation where LED temperature systems, real tank, resembles light, heater, cooler, and water tank in real time. Gauss widgets to display the temperature and volume of the water. And this is all about the presentation of my project, and now I will be showing this in simulator IoT using Blinkit app. Next will be shown now. Now I will explain you code for the home automation system. First of all, we will write all the required header files and libraries into it which are required for designing home automation system. Then we are writing our authentication code. Then we are initializing the variable that are including in it, and we are including library which are required in it. Then we will mention different functions required in it, and we will define all the functions that are required in it. The cooler vpin function by switching it on or off by mobile blink it function. The light control diode will display when the cooler is on or when the cooler is off. The LCD will display the output whether the cooler is on or off. When it comes to the heater pin, it will take the input and it will display on the LCD screen. The inlet pin will display the inlet valve of water tank, and it will enable the pin and will show on the screen whether the water tank level what is it is, whether above 2000 or whether it is below 2000. Same on the outlet valve, it will take the input whether it is on or off, and it will show on the outlet and disable outlet. The app will senses the temperature and it will show as the temperature is moving. Even the water level is displayed on the mobile app. When the temperature exceeds 35 degree, the heater will get off and it will be displayed on the LCD screen. And when the water level is less than the 2000, the inlet valve is on and the inlet valve position will be displayed on the LCD screen. When the water level is above 2000, then the outlet bulb will be get on and it will be displayed on the LCD screen. That is all about the home automation system, and overall it is shown in simulator app.